Can you hear me now?
Yeah.
Okay, you hear me now. Good. Yes, sorry. Uh, the Compost Main is for state school UK students. There's Compost Foundation. Foundation. This is for private schools, private and overseas students. So here, this is free to participate. There are fees here to pay because we are not funded we're not funded for private and overseas students, so they can join for a fee. It's a very reasonable fee, much less than you would pay for a tuition course or anything like that. And there is Compost Follow Along. Compost Follow Along. So there's no difference between the first two. It's the same. You have tutorials, reels in small groups, groups. You have, I mean, the Miro board. The Miro board, yes. There are webinars. This is what we have now. And there are 10 assignments. And you are expected to, the assignments are mandatory. So there are, you are expected to do 75% completion in the number of assignments, not 75%, not the score in each assignment, just 75 completion. Assignment is completed if you've done approximately 50%, but we're flexible with that, right? Tutorials in small groups. This is, you are expected to have 75% attendance. The follow along program, you have no tutorials, you just have webinars, and you still have 10 assignments, but we are unable to give you feedback, right? You don't have tutorials, you don't have a tutor. You can do assignments, and if you complete the follow-along course, you will be treated as a Compost Main student, so you will receive recognition that you have completed the course. It's a letter of recognition that you have completed the course, and you will be invited for the Compost Main for next year, so for year 13. Tutorials start on the 4th of November. Start 4th November. Okay. All right. Yes, people can hear me. Right. So in terms of the chat, we have a moderator today, so hopefully it's going to work better. All right. So please. Okay. Right. And moving on. So 10 assignments. So for the Compost Main, well, there are approximately 450 places for Compost Main. Compost Foundation, we are not limited with places because basically we're limited by the money we have in Compost Foundation because they pay fees. pay for their tuition, basically. And yes, 10 assignments which are not mandatory. Not mandatory. Sorry. Now, tutorials in small groups start on the 4th of November. You are expected to do 4 to 5 hours homework every week. Okay, maybe 3. You can get away with 3, but 3 to 5, certainly. That's the expectation. So it is a commitment. All right, COMPOS is a commitment. It's large. If you really like physics and math and you want to spend that time, please join. It's what we don't want is you joining COMPOS main and then realizing, nah, I don't want to do it, and just and then we lose a place because somebody else wanted to take your place. So if you're not sure, better to join follow along, and you can join COMPOS next year if you are successful in the follow along. Okay, so that's it. That's about it. So let's talk about coordinate geometry, and we talk about vectors first. Now, the problem 1 is quite simple, but it gives you an idea on how vectors work. So imagine we are on a grid. So this is a 6 by 6 grid, and each step in the size of the grid is 1. That means if the mouse moves forward by 1, we say the mouse moved by vector 0, 1, because that's the movement of the mouse. You could also say that this is vector j. So j is up, that's the unit vector, and I is this vector. So if you want the mouse to reach the cheese, you go j, then I, j, minus I, plus j, 1, 2, 3, 4, 5, and j. So if the mouse wants to reach the cheese, it's 2 j's plus 3 i's plus 2 j's minus 2 i's plus j plus 5 i's plus j. And if you add these all up, you will get 2, 2, and 2. That's 6j. That's a vector. And I is 3 minus 2. That's 1 plus 5. That's 6i. Okay. How much does COMPOS cost for private students? It's £25 per week. So for the year, for the whole year, it's approximately £900 or something like that. COMPOS, yes, COMPOS main follow along. Follow along. You don't have small tutorials in small groups, which haven't started. These are start only on the 4th of November. Okay, but you can also write these as column vectors. So the mouse moves by vector 0, 2. Then the mouse moves by vector 3, 0, 0, 2, minus 2, 0, and then 1, 0, 0, 1, and then 5, 1, 5, 0, and 0, 1. And if you add all of these vectors, 0, 2 plus 3, 0 plus 0, 2 plus minus 2, 0 plus 0, 1 plus 5, 0 plus 0, 1. If you add all of these up, you get 6 and 6, vector 6, 6. So it's equivalent. The mouse moves from the left corner to the cheese, and the vector is 6, 6. I hope that makes sense. This is maths, coordinate geometry. Okay. There was a question, how long does COMPOS main last? Until the 7th of July. Start, end, 7th July. Okay. Problem 2. So we're still talking about vectors. The Martian rover trundles 5 meters at 37 degrees northeast, and then 10 meters at 60 degrees west of north. What is the magnitude and direction of its net displacement? What vector should be given to return to its starting position? Can you show that the answer is both the magnitude and also in the IJK format? Okay, so there are different ways you can approach this. So let's say 5 meters, 37 north of east, of course, north of east. So that means let's start from A. We have 37 degrees north of east. So we go like this, 5 meters. 5 meters at an angle of 37 degrees north of east. And then 10 meters at 60 degrees west of north. So that means it goes like this. So this is 60 degrees and it goes 10 meters. Okay, the picture is not perfect, but okay, 10 meters. So this is point B, and now it is at point C. So how can we approach this? Well, we can write down the coordinates of vector AB. I personally prefer column vectors. Some people prefer IJK format. Well, there's no K, but yeah. So A to B to C. So I'm going to write vector AB as a column vector. It's the horizontal component of vector AB, and the vertical component of vector AB. And the horizontal component is certainly 5 multiplied by cos 37 degrees. And the vertical component is 5 sine 37 degrees. Do you understand what I've just did? On a scale of 0 to 10, please. Okay, confident. Oh yes, thank you for the link. Okay, so mostly 10s, some with a sprinkle of 6s and 8 7s. So I'm using trigonometry. So this is a right angle triangle. This angle is 37. This is 5. So if I want to find x, then I write cos 37 is x over 5, is adjacent over hypotenuse, and therefore x is 5 cos 37. So you can say that AB has a horizontal component of 5 cos 37. We do this a lot in physics and mechanics. And this component is 5 sine 37. So the vector AB has two components, 5 cos 37 and 5 sine 37. Hope that makes sense. Now for the vector BC, it has two components as well. So BC has a vertical component like this and a horizontal component like this. This angle is 60. So I'm going to say that this component is 10 cos 60, and this is 10 sine 60, except it going left, so it's minus 10 sine 60. So BC is 10 minus 10 sine 60, and 10 cos 60. So if you want to find the vector AC, vector AC is simply AB plus BC. AB plus BC. And then you just add them. 5 cos 37 minus 10 sine 60. 5 sine 37 plus 10 cos 60. You add them up. So 5 cos 37 minus 10 sine 60 which is minus 4.67, and then 5 sine 37 plus 10 cos 60. That's 8.01 meters. So if you want to go from A to C, A to C, AC, A to C is 4.67 meters left and 8.01 meters up. Or you can find the angle. Well, to find the angle, it's reasonably straightforward. So you can say, okay, this is north. So you go this way. So this is 467, and this is 8.01. So this angle, theta, is arctan. It's the inverse tan of 4.67 over 8.01, which gives you arctan 67 divided by 8.01. It's 30 degrees. 30 degrees west of north. West of north. That's it. Is the letter for following students the same as the letter for the main students? Yes. Letter is the same. Okay, lovely. Moving on, still doing vectors. You're given 3 vectors. 3 to k. So I really like vectors as columns, because a column is just so neat, and this I find that isn't. But it's up to you. It's whatever you like. There's 3, 2, minus 1. B is 2 minus 1 k. And C is 1, 3, 0. Okay, find A plus B. So A plus B is easy. A plus B is 5, 1, minus 1 plus k. Oh, sorry. That's 1. What am I doing? It's 1. Of course, it's like k. Right. It's minus 1 plus 1. That is 0. A minus B is 3 minus 2 is 1. 2 minus minus 1 is 3. Minus 1 is minus 2. AX, that is the x component of A. The x component of A is 3. That's super easy. The y component of B is -1. And the z component of C is 0. Make vector B 4 times larger. Easy, you multiply it by 4. So that would be 8 minus 4, 4. Rotate vector C by 90 degrees clockwise. Give the new vector. It's a horrible question because it doesn't say this is a 3-dimensional vector. So it doesn't say which way to rotate, but we assume that it is in the xy plane because vector C is in the xy plane. So this is x, this is y. So C is, if you put C in this plane, it's going to be 1, 3. So 1 and 3, 1, 2, 3. So vector C is 1, 3. It's like this, 1, 3. And then we rotate this vector 90 degrees clockwise. Well, you can imagine how it goes. It goes here. It goes 1, 2, 3. 1. It goes like this, 90 degrees clockwise. Degrees clockwise. You could do complex calculations if you wish, but honestly, it's just 3 minus 1. So that would be 3 minus 1, 0. Z is just the Z component is 0. It doesn't change. Right. Now, it says to find AI. This is a dot product. The dot product. Sorry, I will answer the questions at the end, like in regards to the COMPOS program. AI. So I is a column vector, and it's 1, 0, 0. And A, we already know A. So A multiplied by I, it's a product of two vectors, which is 3, 2, minus 1, multiplied by 1, 0, 0. And the way we multiply vectors is 3 times 1 is 3, plus 2 times 0, 0, minus 1 times 0, 0. So that's 3. So the dot product of A. But A times I is actually the same as AX. The X component of A is the scalar product of A on I. That's a interesting result. The X component of A is the dot product of A on the vector I. The Y component is the dot product of A onto the vector J. And AZ is the dot product on vector K. Yeah, we have three base vectors. So base vectors, I is 1, 0, 0. J is 0, 1, 0. And K is 0, 0, 1. So these are three vectors that form the basis, something that's just called the basis of our Cartesian coordinate system. So this is X, this is Y, this is Z. This is a 3D coordinate system. And vector I is this vector, vector I. Vector J goes along the y-axis. And vector K is a vector along the z-axis. This is what ijk is. When you're doing vectors, that's what ij and k are. The dot oh, what is the dot product? Didn't we mention in the assignment? Is dot product not mentioned in the assignment? I'd be very surprised if it's not mentioned. It's in the assignment. Yeah, I'm not surprised. So yeah, here's the dot product. Yeah, so read about this. There's a video link here you can watch. Yeah. Okay, so now we're moving to coordinate geometry. So we've kind of done with, no, we've not done with vectors certainly, because we'll be doing more vectors further on. Yes, thank you for the link. Right. So this is just a coordinate. This is an A-level question, by the way. So it's reasonably relaxed. A circle has equation. So find the coordinates of the center of the circle. Well, there are different ways you can do this, but the main way you do is you complete the square. So from here, you can complete the square. So x squared minus 4x, you need a plus 4 to complete the square. Plus y squared. And then this is 4. So it's minus 4 and minus 14, minus 18. Okay, minus 18 equals 0. And so this is x minus 2 squared plus y squared equals 18. So the center is at 2, 0. And the radius of the circle is square root of 18, which is 3 root 2. So the coordinates of the center of the circle is 2, 0. The radius of the circle, find the radius of the circle in the form p root 2, where p is an integer. Well, we've done that, 3 root 2. Where is the 4 when completing the square? Okay. What is a complete square? Complete square is an expression. So complete squares. So x plus 1 squared is a complete square because it's x squared plus 2x plus 1. Well, it's vice versa. 2x plus x squared plus 2x plus 1 is a complete square because it can be written like this. X squared plus 4x plus 4 is a complete square because it can be written as x plus 2 squared, etc. The list goes on, x plus 6, x plus 9. So what we have here is we have x squared minus 4x plus y squared minus 14 equals 0. Well, this is almost a complete square, except it's missing a 4, because we know we need a 4 to complete the square. So what we do is we write plus 4 here, and we add a minus 4 at the end, because that will compensate for the extra 4. And this turns to x squared minus 4x plus 4. And then this becomes minus 18. Does that answer your question, Avi? Okay. Right. So a chord of the circle has length 8. Find the perpendicular distance from the center of the circle to this chord. Okay, so this circle has radius 3√2, and there's a chord which has a length of 8. Well, we can draw the chord like this. We can draw the chord like this. This is 8. And this is another radius, which is also 3√2. I'm going to draw the height of the triangle like this. And this is going to be 4, and this is going to be 4. So if we look at this triangle, this is 4, this is 3√2. And so the perpendicular distance that we're looking for, that's h, is h here. You can use Pythagoras theorem. So we have, this is question B. Pythagoras theorem, so h squared plus 4 squared equals 18. So h is square root of 2. H is square root of 2. A line has equation y equals 2x minus k. 2k minus x, sorry, where k is a constant. Show that the x-coordinate of any point of intersection of the line and the circle satisfies the equation. Okay, so let's visualize this because it doesn't help much. So we have the circle, which is x minus 2 squared plus y squared equals 18. So that's our circle. And we have a straight line with equation y equals 2k minus x, is it? 2k minus x, yes. Because k is unknown, it doesn't give you anything. But you can add a slider k. So in this particular case, k is 1. But if we change k, you can see that the line changes position. So if k is minus 3, it goes like this. If k is 2, it goes like this. If k is 0, it's like this. K is 1, 2, 3, etc. So by changing k, we change the position of the line, which is quite cool. We can take a snapshot of that. It's another tool, by the way, when you're doing questions. You can use technology, of course. You can't rely your answer on technology, but you can use it to assist you. Such as Desmos. Desmos is a powerful tool. So yeah, I mean, show that the x-coordinate of any point. So in this particular case, we have 2 points of intersection. So this is x1 and this is x2. Show that the x-coordinate, well, that's straightforward, because what you need to do is, so this is question C. You have x minus 2 squared plus y squared equals 18. And you have y equals 2k minus x. So all you need is substitute y into this expression. So x minus 2 squared plus 2k minus x squared equals 18. You open the brackets, x squared minus 4x plus 4 plus 4k squared minus 4kx plus x squared minus 18 equals 0. And then you place everything with x squared, so 2x squared minus 4x minus 4kx minus 4x minus 4kx, and then we have plus 4k squared minus 14 equals 0. And then it's, oh, it looks like you can divide by 2, the whole thing divide by 2. So it's x squared minus 2x minus 2kx plus 2k squared minus 7 equals 0. And we combine these two. So x squared minus 2. Oh yeah, minus 2. K plus 1 x minus plus 2k squared minus 7 equals 0. That's what we wanted. Find the values of k for which the equation has equal roots. Find the values of k for which the equation has equal roots. So that's II, CI, and II. Well, this is a quadratic equation. A quadratic equation has equal roots when the discriminant is 0. So the discriminant is b squared minus 4ac. In this case, the discriminant, this is b, this is c, and a is 1. A is 1, this is b, and this is c. So the discriminant is b squared, which is 4k plus 1 squared minus 4, 2k squared minus 7, and that is 4k squared plus 2k plus 1 minus 8k squared plus 28, and that must equal to 0. Why? Because when the discriminant is 0, so repeat roots, or what do they call it? Equal roots. Equal roots is when the discriminant is 0. Equal roots when discriminant is 0. Okay, so we found the discriminant is 0. Now we just solve for k. 4k squared plus 8k plus 4 minus 8k squared plus 28 equals 0. So that is minus 4k squared plus 8k plus 32 equals 0. You can divide by minus 4. That's k squared minus 2k minus 8 equals 0. K minus 4, k plus 2 equals 0. So k is minus 2, k is 4. Right. So these are the situation when the equation has repeat roots. Repeat roots. So, but what does that mean? Let's look at the previous diagram. So k is minus 2. That's when the two x's are the same. Look, now x's are different. X's are different. By x's, I mean the coordinates of the 2 points of intersection. And then suddenly, when k is minus 2, the two x's are the same. So this is what repeat roots mean. Repeat roots, when you have a circle and a straight line, repeat roots means that the line is tangent to the circle. Repeat roots means the line is tangent to the circle. Okay. Okay, moving on. Find the equation of the circle inscribed into triangle ABC. Find the equation of the circle that is inscribed into triangle ABC. Well, obviously, the first thing I would do is just try to draw it and try to make sense of the problem. You can also use GeoGebra. Let's use GeoGebra. And yes, so tools, point. So it's to tool. It's 2 to 8. To 8. Is it? 2, 8 and 6, 5. And 6, 5, 6, 5. Okay, so now we can draw a segment. We can find we know that the tangent is the inscribed circle is where the angle bisectors meet. So I'm going to use angle bisector. So here we are. This is an angle bisector. And I'm going to use an angle bisector here. So where the two angle bisectors meet, that's the center of the inscribed circle. Now, if I draw a circle, here we are. And all I need is to just draw a segment of DE, and that's my radius, and measure the distance. Okay. You can't do it like that in the assignment, of course. Yeah, you can do this, but you can't say this is my solution. This is not a solution, right? This is just technology to help you. But this gives us an idea of what we're dealing with. So here we are. You would notice something interesting, that you notice that this length is 5 and this length is also 5. So it's this isosceles triangle. It's an isosceles triangle, and we are looking for the intersection of the angle bisectors. So this is an angle bisector. So this angle is equal to this angle, and this angle bisector. Well, it doesn't matter which one you use, but let's say this one. This is the center of the in circle. So this angle is equal to this angle. Now, if I actually were to draw this in circle, you would notice that this is the radius of the in circle, but also this is the radius of the in circle. So you can give the coordinates of this point in terms of r. We know that the coordinates is 2 plus r, right? The x coordinate is 2 plus r. And on the other hand, the coordinate of this, well, is 5. The y coordinate is 5. 2 plus r in 5. That's this point. This point, well, let's label it as xy. What do we know about xy? Well, we know that it is on this line. The point at xy is on the BC line. So let's find the equation of line BC. Line BC. If you have 2 points, x1, y1, and x2, y2, you can write down the equation of a line using this equation. Y minus y1, y2 minus y1 equals x minus x1, x2 minus x1. Therefore, that is y minus y1, so b is 8 over 5 minus 8 equals x minus 6, no, x minus 2, and 6 minus 2. Okay, so from here, y minus 8 over minus 3 equals x minus 2 over 4. Y is equal to minus 3/4 x minus 6/4 plus 8. So y is minus 3 over 4x. 32 minus 6, 26 plus 26 over 4, I believe. Okay, 26 over 4 can be simplified as 13 over 2. 13 over 2. Okay, so you find this equation as the equation of line BC is y equals minus 3/4, right? So this point, x, is x, and minus 3/4 x plus 13 over 2. All right, it's not x1, it's just x. All right. Not sure that helps. The angles. Still have 2 unknowns. Or x is an unknown, and y and yes, you can use. Is it possible to calculate it by 3 lines in its tangent to get the circle? Just a second. Sorry. Yeah, I mean, it was a bit silly of me. Okay, to find x, because we know that BM, let's say BM is 3, and BN is also 3. Okay, so using the fact that BN is 3, we can work out x, because that means, because B is 2, 8, that means that Bn is 3, And then that means that's the square root of 2 minus x squared plus 8 minus 8 plus 3/4 x minus 13 over 2 squared is 3. Okay, so we work that out. So 2 minus x, that's 4 minus 4x plus x squared. 8 minus 13 over 2, that's 3 over 2. Yes, that's 3 over 2. 3 over 2 with a plus. And can we 3 over 4, open bracket, x plus 2 squared equals 9. There's a plus. So x squared minus 4x plus 4 plus 9 over 16. X squared plus 4x plus 4 equals 9. Oh, this is a common, these are like terms, so it's 1 plus, that's 25. 25 over 16 times x squared minus 4x plus 4 equals 9. So x minus 2 squared is equal to 9 times 16 over 25. X minus 2 is 3 times 4 over 5. So x equals 12 over 5 plus 2, which is 22 over 5. 22 over 5 is 4.4, which makes sense. Yes, this is 4.4. So this is 4.4, comma, something, comma, so we need y. Y is minus 3/4 multiplied by 22 over 5 plus 13 over 2. 13 over 2, which is, okay, I didn't realize it's going to be so convoluted. 33 over 5 plus 13 over 2, which is 66, 65 minus 66 over 2 is minus 1/2. That doesn't make any sense. Oh, thank you. Yes, they're not like terms. That was wishful thinking on my side. Yes, thank you. I was hoping that at least something would go as planned here, but yeah, x squared minus 4x plus 4. Okay, let's multiply the whole thing by 16, and 9 times 16, whatever that is, so 16 times that plus 9 x squared plus 36x plus 36 equals 9 times 16, 144. 16x squared minus 64x plus 64 plus 9x squared plus 36x plus 36 equals 144. 25x squared, 32, 20 minus 28. Seriously? Okay, minus 44 equals 0. 36 minus 64, 36 minus 64, 28, yeah. Okay, so we solved the quadratic. I'm going to be a bit lazy, so I'm just going to plug that quadratic into my calculator. 28 minus 44. And there are two solutions, x equals 2, and x equals minus 22 over 25. So this second option is clearly not right. But, oh, neither is the first one. I'm not sure what's going on. Maybe my equation is incorrect for b, minus 3/4 x plus 13 over 2. Yes, it is incorrect because it's not possible. It's more like 18 over 2. Where did I go wrong? 32 minus 6. 32 minus 6 is 26 over 4. 13 over 2. Okay, sorry. BM to B3, because M is this point. M is 2, 5. 2, 5. B is 2, 8. And so that BM is 3. Now these triangles are congruent because they have the same angle, the same opposite side, and so they have same three angles, and two sides are the same. And one side is the same. So that means they're congruent. That means this BN is 3 as well. But this can't be right. So I do apologize. How much time do we have? Okay. Let's see what. No, I've deleted it. Okay, so I think this is wrong. X, y minus 8, x minus 2, 5 minus 8, 6 minus 2. 6 minus 2 is 4 minus 3. Okay. So 4y minus 32 equals minus 3x plus 6. Y equals minus 3 over 4x plus 32 plus 38 plus 38 over 4. Okay, so what have I done wrong? Because it's minus 3, of course, it was 6. 38 over 4, which is 19 over 2. 19 over 2. Yes, not 18, 19 over 2. So this is plus 19 over 2. Plus 8. 8 minus 19 over 2, which is minus 3 over 2. That is ridiculous because they were. Okay, I made two mistakes, but I had the correct answer initially. The initial answer was correct because they were 16 plus 9, so that's 25 x minus 2 squared equals 144. So x minus 2 squared is 12 over 5 without the square. X equals 22 over 5. So that was the correct answer. All right, so this is wrong. 22/5. So n is 22/5, and then minus 3/4, 22/5. So y is minus 3/4 multiplied by 22/5 plus 19/2, which is that's 2, 11, 33/10 minus 33/10 plus times 5, 70, 78, 19 times 5, 19 times 5, oh, 95, sorry, 95, 95 over 10, which is 62 over 10, which is 6.2. 6.2. 6.2. And now you can work out R, because you know that the distance between this point, O, ON, is R. And that means that 2 plus R minus 22/5, I'm using Pythagoras, squared, plus 5 minus 6.2 squared is R squared. Let's expand this. R minus 12/5 squared plus 5 minus 1.2 squared, so 1.44 equals R squared. R squared minus 2R times 12/5. Yep, plus 144/25 plus 1.44 equals R squared. R squared cancels to our delight because we don't have to deal with squares. And now we have 24/5 R equals 4/100. So that's 4 times over 100, which is 5. 5 multiplied by 144/100, which is 25. So 24R equals 144/4, and R is equal to 144/12 times 2 times 4. 44, 12, 12, 12 divided by 4 is 3. 3/2 is 1, 3/2. That doesn't make any sense. That wasn't the answer we had, but maybe it is. 1.5. So they're saying that the answer is, well, my math is saying that the answer is, that the radius is 3/2. That means that the circle has equation of the circle. I'll change color. Equation of the circle. Of the circle. We worked out that the center of the circle is 3.55. So that means that it is x minus 3.5 squared plus y minus 5 squared equals 3/2 squared. That's the equation of the circle. Apologies. This has been way too long. It took me way too long to do. When I was preparing, I didn't get to the end. I was like, oh, there's a final step, and the final step turned out to be horrendous. But okay, I was a bit lazy today. Anyways, moving on. Find the angles between lines AD1 and AB1. AD1. I wonder how many people we still have left because oh, we actually have more. Okay. AD1. So the best way to do this is to do vectors. There's an interesting thing that the angle between vectors, between two vectors, and that's very important. Theta is the dot product of the two vectors divided by the modulus of the first vector multiplied by the modulus of the second vector. So in order to find the angle between lines AD1 and AB1, of course, we could use common sense actually here. But I'm not going to use common sense. The common sense would be that this is an equilateral triangle, right? And that the angle would be 60. But I'm not going to use common sense. I'm going to use vectors. So I'm going to say that vector this, let this be the x-axis. Let this be the y-axis. And let this be the z-axis. And let the cube to be of side 1. So this is 1, this is 1, and this is 1. This means that vector AD1 is x plus z. So it is 1, 0, 1. Do you understand why AD1 is 1, 0, 1? On a scale 0 to 10, please. How well do you understand? It is 1 step along the x-axis, 0 steps along the y-axis, and 1 step along the z-axis. That's what it means. 1 step along the x-axis, 0 steps along the y-axis, and 1 step along the z-axis. If you want to go from A to D1. If you want to go from A to B1, what would that be? Type in the chat, please. 0, 1, 1. Yes, well done. 0, 1, 1. Very good. So it's 0 steps on the x-axis, 1 step on the y-axis, and 1 step on the z-axis. So if you want to find the angle between AD and AB1, so the angle between AD1 and AB1, oh sorry, cos of the angle, of course. So the cos of that angle is the dot product. So the dot product is 1 times 0 is 0. 0 times 1 is 0. And 1 times 1 is 1. 1 over the length of this vector. So it's the square root of 1 squared plus 0 squared plus 1 squared. That's the length of this vector. Multiplied by the length of this vector, 0 squared plus 1 squared plus 1 squared, which is 1 divided by square root of 2, which is 1 over 2. But that means that the angle, let's call it theta, this notation for angles is ridiculous, is our cos of 1/2, which is 60 degrees. But we got the same result when we saw that this is actually an equilateral triangle, because this side is equal to this side is this side, so this is 60 degrees. So it makes perfect sense. Okay. Now let's do the same with the other two, B1 D1, B1 D1, and AC. Well, There's nothing new. B1 D1 is 1 on the x, 0 on the z, and -1. Sorry, 0 on the z and -1 on the y-axis. AC is 1 on the x, 1 on the y, and 0 on the z. 1, 1, 0. And then you find the cos. So cos theta is equal to 1 minus 1 plus 0 over whatever, because this is going to be 0. And theta is arc cos 0, which is 90 degrees. So the angle between these two vectors is 90 degrees, and it makes perfect sense because if you were to move this top vector, if you were to move this vector here, that would be 90 degrees. Okay. So the rest is the same. Find the angle between planes. Find the angle. So this is done similar to these two. Find the angle between the planes ADC. ADC. So can I? ADC and AD1C. ADC. Oh, that's the bottom plane. ADC. AD1C. Ooh, that's an interesting one. AD1C, that's the plane. Okay, so you can use geometry or you can use vectors. It's up to you. When you're talking about two planes, let's say you have plane.
Wait, sir.
Yeah.
Why is vector A times vector B 0 plus 0 plus 1?
Just a second. I'll have a look. I'll just get this picture. Copy image. Right. So which ones in this one?
Yeah,
So you multiply 1 by 0, and that makes 0. Then you multiply 0 by 1, and that's 0. And then you multiply 1 by 1, and that makes 1.
sure.
Okay, so here, in similar way, 1 times 1 is 1. Minus 1 times 1 is minus 1. And 0 times 0 is 0. Okay?
Yeah,
So when you multiply two vectors, you multiply their coordinates and add. Okay. Right. So if you have two planes, two flat surfaces, you can have it doesn't you can't necessarily see the angle between two planes. What are we talking about? It's this angle. But a plane is not a vector, but you can make it into a vector. Because look, If you draw a vector called the normal vector, normal to alpha, it's the normal vector. A normal means perpendicular to the plane. So if you have a plane and a vector perpendicular to that plane is called the normal vector. The vector perpendicular to beta, let's call it normal vector to beta. And let's look at this view from the side. So this is plane beta, this is plane alpha. You're looking for this angle, theta. But you are finding the angle between this vector and this vector. So you will find this angle. You will find this angle between the two vectors. But if you find this angle, you also know this angle, which is the same. This is 90 degrees, this is 90 degrees. So you would find how do we call it? Let's call it angle delta. Delta. This is angle delta. And you can see that theta plus delta is 180 degrees. Because of the way, because it's a quadrilateral, and these are 90 degrees. Because these are normal vectors, normal 1 and normal 2. You're looking for this angle. And if you do if you find cos theta is cos 180 minus delta, which actually is minus cos delta. Okay, so what you will find is you will find the angle between the two vectors, and that's delta. But the cos of the angle between the two planes is actually just minus the cos of the angle between the two vectors. But then, on the other hand, if you take this is also 180 minus delta. So it's the same thing. So you could say that the cosine of the angle between the two planes, of the angle between two planes, is just the same. It's the normal vector to the plane 1 multiplied by normal vector to the plane 2 divided by the modulus of the normal vector 1 multiplied the modulus of the normal vector 2. I hope that makes sense. Sorry, I hope I didn't confuse you. What I'm trying to say that these are the two planes. If you find the angle between these two vectors, then cosine of that angle, delta, is going to be minus cosine of this angle, theta. That's what I'm trying to say. And you actually need to take the modulus. You take the modulus of that because two planes always have two angles. You have this angle, theta, but you also have the angle 180 minus theta, which is delta. So which angle are you looking for? The obtuse one or the acute one? We usually find we're usually looking for the acute angle. So if you get a negative cosine, that simply means you just take the modulus of that. So what we need to do to find the angle between the planes ADC ADC, ADC. We need to find a normal vector to ADC. And this vector is A1. So this is the normal vector to ADC. Normal. So vector A1 is normal to ADC, to the plane ADC. Now we look at the plane AD1C. AD1C. This is the plane. The normal vector to that would be DB1. DB1 is the normal to AD1C. And then you repeat what we just done before. So A1 is 0, 0, 1. DB1 is -1, 1, 1. And then you find the angle. Y cos 80 minus D is minus cos D. Well, Saad, no, it's a good point, but that's not the reason. Well, it's the straightforward reason, cos 180 minus x is minus cos x. Why? Because cos A minus B is cos A cos B minus sine A sine B. And then cos 180 minus x, using this formula, is cos 180 cos x minus sine 180 sine x. And then cos 180 is minus 1 and sine 180 is 0. So it's minus 1 cos x minus 0 sine x, which is minus cos x. That's one of the reasons.
Sir.
Yep.
Are we meant to know this? Like
This
what you said, yeah.
Technically, that's assignment 2. So it's the next assignment, but it is part of A levels. I mean,
okay.
Yes, at some point in this year, you're supposed to learn that. Yes,
Oh, okay.
you're supposed to know
you.
that. But you can also, it makes perfect sense, because if you do cos 120 is minus a half, but cos 60 is a half. And 120, so cos 180 minus 60 is minus cos 60. So you can verify this. This is anecdotal evidence, but yeah, you can just verify that formula that it does work for all values. So here, you don't need to know the explanation, but you do need to know the result. If you want to find the angle between two planes, you just need to find the angle between two vectors, two normal vectors. A normal vector is perpendicular to the plane. So if you have a plane, this is the normal vector. If you take another plane and it has a normal vector, all you need is to find the angle between the two vectors. The angle between two vectors is the angle between the two planes. And if you get an obtuse angle, you just do 180 minus that angle, because a plane always has two angles, right? Because if you have the acute angle between two planes, but also the obtuse angle between the two planes. Both are equally valid. That's what I'm trying to say. And I hope that that makes sense. Well, that was intense. I haven't done 2 more questions. I'm ready to answer a few more of your questions about the course and even on the questions themselves, but I probably won't be able to answer all the questions. I really hope you've learned something new today. So type 1 if you have learned something new today, and type 0 if you haven't. Okay, thank you. I saw the question, who are the tutors for the main tutorials? So we have approximately 35 Oxford students. So most of them are doing masters. We have some postgrad students, PhD students. We have a qualified teacher. We have a professional, an engineer doing tutorials, and we have 2 or 3 students from other universities. So we have a Cambridge University, we have a tutor from Birmingham University. But mostly it's Oxford students. Yeah, so your tutor would most likely be an Oxford physics student. Yeah, so I'm not surprised you fell asleep along when we're doing problem 5. How do you find the length of a plane? What do you mean the length of a plane? It's a plane. If it's a plane, it's infinite. If it's limited, then it's a shape. It's going to be a rectangle. So how do you find the length of a rectangle? If the plane is in the shape of a rectangle, you just use the rules for rectangles. Can you re-explain the COMPOS follow-along program? The follow-along program is a self-study program. You receive the assignments, you can submit them, but you don't receive feedback until the end of the year. At the end of the year, we mark all the work, and if you've completed 75% of the assignments, you will receive the same recognition as a normal COMPOS student. So basically, you can get a COMPOS recognition but not even if you don't get into COMPOS. All students who don't get into the main program automatically are invited to the follow along. Going to do a physical math next week. Next week there's no webinar. It's a bit too intense for me. We are doing admissions, so no webinar next week. Does a webinar increase chance of getting in? Well, it's there's for question 5, I think maybe you took equation of line BC as equation of radius. No, I just made an arithmetic mistake. I put minus instead of plus. Why do we add the products together to get the dot product? Well, it's in the assignment, so please read page 2 of the assignment, and there's a link that explains everything. So please do that. Does joining a webinar increase the chance of getting in? Well, hopefully that means that you spend more time studying with me. That helps you do the assignment, and then you do better. We normally accept students who got more than 50% or more on the first assignment, but we can't guarantee this. But I can say that we have the same number of applicants this year as last year. So we're not expecting a huge increase in competition. Why is chance of getting in? Why is DB1 normal to ADC? Because it's perpendicular. Why is it perpendicular? Well, I'm using symmetry. I'm just thinking BD. if you take a cube and you put it on its corner, that's how it goes. It makes sense. I can prove it, but it just takes time. I cheated a little bit, Rory. So yeah, you caught me there, but it is perpendicular. Okay. Is everything taught we're going to learn in a level or in A level or more? The COMPOS program is slightly above A level, so you will be studying. You won't be studying new topics, but you will be studying at a deeper level than A level, if that makes sense. Okay, so the problems that we do, especially in physics for COMPOS, are closer to university than to A level. Is it too late to start assignment 1? No, it's not too late. You can start assignment 1 and you have 2 weeks to finish it. I thought the 10th of October, yes. Well, I wouldn't know if you have enough time. How do you submit the assignment? You should have received an email how to submit assignment 1. It's done through a Google form. I'll show you the Google form. So COMPOS. Oh wow, we have 6 people already submitted work. Okay, so this is the form that you use. You will need to, you have received a link via email. If not, check your spam inbox because it might be there, because spam filters don't like Google Forms for some reason. You need to put your email, your COMPOS ID, very important. You should know your COMPOS ID. And then you submit problems, math problem 1, math problem 2. You can submit PDF or drawing or images. Okay. There's a video instruction on how to submit, which was also sent to you by email. So please check your spam inboxes. Okay. How do you submit this? When is the first assignment due? 10th of October. Yeah. Can you explain the concepts of radius vector, please? Probably not. I've done this several times. The radius vector, we have our amazing YouTube channel. Well, amazing-ish, because mostly it's just me. And yeah, I consider myself of questionable amazingness, but there are playlists. So here's a link. If you go to COMPOS Year 12 webinars, there's 77 videos and they have names. And if you click vectors in physics, that's actually the first one. Vectors in physics, it has a in-depth explanation of radius vectors. Okay, then how many applicants were last year? Same as this year, 2,500. But don't let this discourage you, because more than half of the people don't submit anything for assignment 1. They just open the assignment 1 and say, "Oh, I'm not going to do that." So it's about half the people who submitted the first assignment got in. If you complete a question in the assignment via a method that's different from the markers we expect, we receive full credit. Yes, unless the question specifies that you need to do this method. When is the next webinar? I will send an email to everyone. I'll send an email to everyone. Yes, is the same certificate in Compass Main Foundation following? Yes, that's the same certificate. It's not a certificate. It's a letter. It's a Oxford headed letter. Since you mentioned there will be some year 13 content, year 12 Compass now, what will change? Well, the first topic has changed because we used to have vectors for the first topic, and now it's coordinate geometry. That's one of the changes that we've introduced. Some of the year 13 topics moved into year 12, and some of the year 12 topics moved into year 10. So yeah. How do we know if we can accept for Compass program? Once you submit the work, we'll try to mark everything within a week, and you will receive an email saying you are in, and asking you to provide your availability, because based on your availability, we will choose a group for you. So if you say you're available on Tuesday afternoon, we will find a tutor who's available also on Tuesday afternoon. So that's it. But try to be more flexible. All right, I'll stop here. And thank you for your attention. And yes, see you in 2 weeks, probably, maybe 3. All right, but I'll keep you posted. See you, everyone, and good luck with assignment 1.